I'm Pat Dugas. This screencast is about one of the most important concepts in mathematics, and that is determining the rate of change of functions.
So this idea of rate of change, also known as slope, is one of the most important concepts in mathematics. Understanding how things are changing is critical in our dynamic world. Rate of change is a comparison of how one quantity changes with respect to another quantity. For example, let's say we're going on a road trip to Springfield and we travel 95 kilometers in 1 hour. Our rate of change is a comparison of the distance we traveled, 95 kilometers, to that 1 hour of time that it took us to go that 95 kilometers. And so we know that as 95 kilometers per hour, also known as speed. Speed is one of the most often used examples of rate of change. So mathematically, rate of change is calculated as a ratio of, and you can see that word rate within ratio, of the dependent variables change divided by the independent variables change. In this case, distance depends on time. So we're dividing the dependent variable change, distance, 95 kilometers, divided by the independent variable time in 1 hour. So mathematically, here's the formula. It is the change in the dependent variable divided by the change in the independent variable. You often see it as y2 minus y1 over x2 minus x1, but we need not be restricted to y and x. You see that little triangle there. That is the Greek symbol delta, which means change. So the way we would say this is delta y over delta x. The change in the y values, y2 minus y1, if you will, where y2 and y1 are the y coordinates of the points, and the change in the x coordinates, x2 minus x1, as it's often known. But again, rate of change calculated by finding the change in the dependent variable, in this case distance, divided by the change in the independent variable, in this case time. So in our example, if d was distance and t was time, the rate of change would actually be delta d divided by delta t, the change in distance divided by the change in time. So let's look at the concept of rate of change with the Big Mac and its cost in this century, at least up till 2014. So this is a chart that shows the cost of a Big Mac in US dollars from the year 2000 to the year 2014. In 2000, it was $2.51, and the price has been non-steadily rising until in 2014, it was $4.62. So the question is, how do we find the rate of change of this? Well, if we look at this function, it isn't a constant rate of change. The price only increased 3 cents from 2000 to 2001, but then from 2001 to 2002, it actually decreased. From, for example, 2012 to 2013, it increased from 433 to 456. So in that 1 year, it increased by 23 cents. So it's not a constant rate of change. So what we're going to introduce in this screencast is the concept of an average rate of change. Over the entire period, what was its rate of change? So let's calculate that. Now it's important to note that you can calculate the average rate of change over any interval that you choose. What we choose to do for this example is over the entire period from 2000 to 2014. What is the average rate of change? To be able to do that, we need to identify the independent and dependent variables. Well, in this case, the cost of the Big Mac on the vertical axis depends on time. So the independent variable is time in years. Let's call that t. The dependent variable on the vertical axis is the cost in US dollars of the Big Mac in that given year. So let's call that c. Again, in algebra, you can define variables any way you want. This is just how we choose to do that. So to be able to find the rate of change, we need to find the change in the dependent variable and the change in the independent variable. So the change in cost, delta c, change in the dependent variable, delta c, remember delta means change, is equal to $4.62 in 2014 minus $2.51 in 2000. So we're going to take the more recent one first and subtract the earlier one from it. The difference is $2.11. So over that entire period, $2.11 was the increase in the Big Mac's cost. Delta T, the change of time over that period, was 2014, subtracting from that 2000. So 2014 minus 2000, the period was 14 years. So Delta C, change in cost, $2.11, the difference in the cost, divided by, and Delta T is 14 years over the 14-year period. So the rate of change is the change in the dependent variable, delta C, divided by the change in the independent variable, delta T. Delta C over delta T in this case. So that is calculated as the ratio of $2.11 divided by 14 years. When you calculate that out, you get approximately $0.15 per year, or 15 cents per year. So that's the rate of change of the Big Mac, the average rate of change over the entire period. Was it the rate of change all along? No. As we've seen, the rates of change varied from year to year, but over the entire period, we get a pretty good idea of the average as 15 cents per year. So let's take a look at how you find the rate of change or slope of a line given 2 points on the line in XY coordinate space. Now we're dealing with the dependent variable being y and the independent variable being x. And so let's say we're given 2 points, -3, 6 over here in quadrant 2 and 5, 2 over here in quadrant 1. And we want to find the slope of the line formed between those 2 points. So the way we're going to do that is by finding the change in the y coordinates divided by the change in the x coordinates. Now the change in the y coordinates here, the x coordinate is given first, the y coordinate is the second number. So it is going to be 2 minus 6, that's your delta y. 2 minus 6 is the difference in the vertical or y coordinates here. The change in the x coordinates is the difference between the first two numbers. 5 minus -3. Of course, always be careful with negative numbers. So delta x is 5 minus -3. Delta y, 2 minus 6. So the rate of change of this function is delta y over delta x. Delta y is 2 minus 6, -4. Delta x is 5 minus -3, or positive 8. So the rate of change or slope is -4 divided by 8, or -1 over 2, -1/2. That is the slope of the line that is formed between these 2 points.
This screencast discussed the concept of rate of change and average rate of change of a function.